videos, I've covered defects and discontinuities, but with defects and discontinuities comes weld repairs. It's one of those things that no one likes doing, but to be a great welder, you have to know how to fix your own repairs. You have to figure out why you might have gotten porosity. Was it your tungsten was sticking out too far? Was there some rust or mill scale that you didn't grind off all the way? You have to start thinking one step ahead. Eventually, you won't have to do as many weld repairs after practice and experience, but while you're still learning and still in school, you have to start understanding why. This PowerPoint that I'm going to cover is going to go over how to repair pipe welds, okay? So, pipe weld repairs. The objective. After completing this PowerPoint, students should be able to list common types of defects that have to be repaired, describe some of the causes of weld cracking, identify commonly used tools in the repair of pipe welds, explain the steps used in the repair of pipe welds. Key terms: complete joint penetration, incomplete joint penetration, liquid penetrant, magnetic particle, non-metallic inclusions, wagon tracks, and weld toe. Introduction. Weld repairs on pipes can be extremely expensive to perform and result in the job completion being delayed, which can incur even more costs. Regardless of the cause, it is sometimes necessary to repair some piping, especially with aging systems. Some welds have to be repaired due to unavoidable events such as welding power fluctuation, loss of shielding gas due to a sudden strong wind, or an unexpected event. For instance, an unexpected event occurs on the north slope of Alaska when a bear enters the work camp and an alarm sounds, so the welder must stop immediately. Occasionally, an experienced welder may be asked to repair a weld because of poor work by another less skilled welder. In many cases, these repairs are a result of not following proper welding procedures and practices. Improper preparation often results in discontinuities. One example is not properly cleaning material prior to welding, which can result in defects that must be repaired. Failure to clean slag and silicon in between weld passes can cause inclusions. Porosity can result from poor technique that results in improper shielding of the weld pool. In some cases, fixes may be needed as a result of improper preheating and post-weld heat treatment that can result in hydrogen cracking. The other types of repairs that must be done are as a result of wear related to service, such as erosion, corrosion, silical loading in service, or accidental damage. For the purposes of this chapter, we will discuss repair based on workmanship flaws. This includes the following defects: non-metallic inclusions, lack of fusion, lack of penetration, and porosity. Repair considerations. Things to take into account when making repairs are the location, the length of the defect, and how deep it is within the weld. This can often be determined by a non-destructive testing method. Inspection processes that can be used include X-ray, ultrasound, liquid penetrance, and sometimes visual inspections. The tools that are commonly used in the repair of welds include angle grinders, die grinders, oxy-fuel cutting, gouging torches, plasma arc gouging torches, and air carbon arc gouging torches. So the common thing that you will use in the welding shop here is going to be your angle grinder, okay? Repair considerations continue. The tool that you use is largely determined by the type of material that the pipe is made of, location of the defect, and the length of the defect to be repaired. In cases where the defects are short or are located near the surface, they can be removed easily. Angle grinders range in sizes from 4 1/4 inch to as large as 9 inches. The smaller grinders are easier to use and better for controlling how much metal to remove at a time. The larger grinders are good when you need to remove a lot of metal quickly. A larger grinder is also harder to handle, making control of the tool and precise removal of the defect more difficult. It is also easier to get injured trying to use them. Care should always be taken when using grinders. It is also important to make sure that you read and follow all manufacturer guidelines and instructions when operating them. First and foremost, make sure that you have selected the proper size and type of grinding disc for the job. Refer to the manufacturer's suggestion for the correct disc to use. Some discs are designed for grinding at a 30-degree angle, while others can be used at a 90-degree angle. For grinding and repairing pipe, it is best to select a disc that can be used at a 90-degree angle. This allows the grinder to be tipped up on the edge and grind down in the weld groove. This is important in order to grind the root and do repair work on the welds that are in the weld groove. With that being said, whenever you're using a grinder in the shop, make sure you have on all your correct PPE safety glasses, gloves. Make sure that you have the guard on your grinder. Don't grind or use a cutoff wheel without your guard on there. Non-metallic inclusions. Non-metallic inclusions are typically encountered with processes that use a flux or leave a slag or residential silicon after welding. Non-metallic inclusions are pockets of material in a weld that are not metal. The inclusions will typically be located between weld passes. They are also located along the edge of the weld, such as an element called the weld toe. The weld toe is the junction between the edge of the weld and the base metal. When they are located along this region, they are usually referred to as wagon tracks. The reason for this term is that they look similar to wagon tracks on an x-ray. Typically, wagon tracks would be seen on the root weld pass. This is common because when running a cellulose rod downhill on the root pass, the result is a convex weld. This makes it difficult to remove the slag along the toe. This is why it's important to remove this slag by chipping, wire brushing, or using a needle scaler, in the picture right here, die grinder or angle grinder to clean the root pass prior to making the hot pass. The hot pass can help to eliminate the slag by melting the surrounding base metal and floating the slag to the top of the weld pool, but this does not always happen. With that being said, on that previous slide, you're not going to have to worry so much whenever you are TIG welding, but you will still get that silicone if you're not actually pushing it far enough ahead of you. So with that, you will still have to clean out that silicone, or you will get entrapments whenever you're going over your hot pass, or with your hot pass. Incomplete joint penetration. Incomplete joint penetration is a discontinuity associated only with groove welds. It occurs when weld metal does not extend completely through the thickness of the joint when specifications require complete joint penetration, which is when the weld extends completely through the thickness of the joint. In some instances, incomplete joint penetration is allowable when the specification says so. In this case, it would be referred to as a partial joint penetration weld. Weld performed on pipe that are butt-type joints that form groove joints often will require complete joint penetration. Socket-type welds form fillet joints that typically do not penetrate the joint completely. With that being said, we are welding pipe, so you need to have 100% penetration. So with that being said, it can be flush to 1/8 of an inch, but it can't be underfilled and it cannot go over 1/8 of an inch. Repair of cracks. Cracks are often caused by stresses within the weld. Some of these are the result of making tack welds that are too small for the joint that is being welded. The wrong type of filler metal selected for making tack welds. Insufficient preheating can result in rapid cooling of the tack welds or weld, resulting in cracking. In some cases, higher strength steels require proper pre-weld and post-weld heat treatment to prevent hydrogen cracking that can take place hours and in some cases days after welding. The important thing to remember is to take steps prior to welding that will help to ensure that these type of defects are prevented. Repair of cracks continued. In order to repair cracks, it is important to properly locate where the crack is. The length of the crack and the depth of the crack must be determined so that it can be removed completely prior to re-welding. Surface cracks can be located by using either a liquid penetrant or magnetic particle inspection process. Magnetic particle testing requires that the metal being tested be magnetic in nature. Both of these inspection methods are non-destructive tests and are good for locating surface defects. Magnetic particle can also locate defects that are near the surface. With that being said, I'm just doing a visual inspection, so we're not doing any dye penetrant, we're of course not doing any x-ray, so I'm just going to do a visual inspection. But whenever you get on to the job, you need to understand what they're actually going to do, whether it's going to be destructive or non-destructive testing, all right? Repair of cracks continued. Liquid penetrant uses a solution that is applied to the area that is to be inspected. After a period of time, it is wiped off the surface and a developer is applied that will show any surface cracks. The magnetic particle process uses a magnetic field that is set up around the area to be inspected. A small amount of iron particles are sprinkled on the surface. If there are imperfections at or near the surface, it will disrupt the field and cause the magnetic particles to gather in the area of the discontinuity, revealing the flaw. Once the discontinuities are located, the same technique used in repair of non-metallic inclusions should be used when repairing cracks. So the first step is to determine the length of the crack. Once the length of the crack is determined, it is important to drill the ends of the crack to make sure that the crack does not continue when welding is resumed. If it is not possible to drill the crack, it is necessary to remove the crack completely by grinding. Next, the crack should be ground along its entire length and depth to make sure that it is completely removed. It is important to remember to grind ends of the crack to a feathered edge. We went over what feathered edge means. It means just grinding it down where it's paper thin, which will help to make a smooth transition from the previous weld pass to the next. So, summary. No matter how experienced a welder is or how well a job is laid out, there will be occasions where welds must be repaired. As you are learning, it is a good practice to repair some of your welds that might not meet the acceptable criteria. This will give you invaluable experience that will have an immediate impact on your welding future. Welders who can fix their or other welders' defects are regarded as valuable assets on a pipeline team. With that being said, if you don't get 100% penetration, grind that piece out to where you can go back over it, weld it, and get 100% penetration all the way around your pipe, okay? If you notice any porosity, if you notice any slag inclusions, grind those out and try and fix it. That way, whenever you're turning in your pipe for a grade, you have it 100%, because this isn't necessarily just wanting to get a grade for this class. It's to be the best welder to where you can get the best job out in the field, okay? With that being said, if you have any questions or concerns, please get in contact with me, and I'll go over any of these defects, discontinuities, and how you should be able to repair them. Thanks, guys.